Choropleth Map. And it's not choropleth. There's no L. It's not CHL. It's just choropleth. A choropleth map is a thematic map in which areas are shaded or patterned in proportion to the measurement of the statistical variable being displayed on the map. Choropleth maps are often confused with heat maps, which is a different kind of a thing. Heat maps are usually a grid of colors. Although there is a notion of a geographic heat map, which is more like this. This kind of map is referred to typically as a heat map, but notice how it's not colored polygons. This is something different. This is a representation of density that maybe you could do with kernel density estimation or contour lines, something like that. So this is a heat map, not a choropleth map. A choropleth map has geographic boundaries that are colored. This example in Wikipedia shows the fraction of Australians that identified as Anglican in 2011. Notice how this color legend explains what the colors mean. In this example, color is used to represent a quantitative attribute of the data, using pretty much luminance, which is a channel that has a natural ordering. So you can say, for example, darker means a higher number. That's what a choropleth map is in a nutshell. I want to apply the choropleth map technique to the topic of HIV/AIDS. According to Wikipedia, during 2016, about 36.7 million people were living with HIV, and it resulted in 1 million deaths. There were 300,000 fewer new HIV cases in 2016 than in 2015. Most of those infected live in sub-Saharan Africa. Based on just these very high-level summaries of the phenomenon, I find it difficult to get a complete picture. And this is a case where data visualization can play a huge and very important role. I'm curious to really see and understand the geographic global distribution of HIV/AIDS. And to answer that question of where in the world is HIV/AIDS occurring, a choropleth map is a very good solution. So that's our task. Now we need the data behind this. In researching various sources of data for HIV/AIDS, I found this amazing piece by Our World in Data by Max Rosser and Hannah Ritchie. This is a really nice, deep, exploratory piece that has tons and tons of visualizations about HIV/AIDS. I find this map absolutely stunning. You can see very clearly that sub-Saharan Africa is very disproportionately affected. If you hover over one of these countries, South Africa, it says 18.8% of population ages 15 to 49 have HIV. In Botswana, it's 22.8%. This visualization also has an interactive color legend where you can hover over these bins to see the countries that fall into them. Notice how this color legend is set up. We've got 0 to 0.5 as one color, and then 0.5 to 1% as another color, and then 1% to 2.5% as another color, and then 2.5% to 5% as another color, and so on all the way up to the highest bin, which is everything over 20%. These look to me to be bins that have been hand tweaked to yield a nice looking map. This is a common practice with choropleth maps. You could also use other techniques like quantiles or Jenks natural breaks. Quantiles are cut points dividing the range of a probability distribution, or in visualization, the data domain, into continuous intervals with equal probabilities. So that's what a quantile is in a nutshell, and it's often used as the technique for coming up with those bins to assign different colors. The core idea being that each color should occur approximately the same number of times in the map itself. This typically gives a really nice spread of colors in the map and presents the data pretty clearly. Jenks natural breaks is another approach based on clustering, which you can also use to come up with the color bins for a choropleth map. Each bin is called a class in this terminology. And what Jenks natural breaks does is it seeks to minimize each class's average deviation from the class mean, while also maximizing each class's deviation from the means of other groups. Those algorithmic approaches, though, typically give you numbers that are not readable. They're not like tick marks that are human readable. So it's actually very common to see handcrafted breaks, like in this example here. Just guessing that it's handcrafted, but it looks handcrafted to me. This visualization also goes back in time. You can drag time back to 1990 and then hit this play button to see how the phenomenon evolved over time. But what if we didn't use bins at all? It's totally possible to use a sequential color scale in a choropleth map. The question, to bin or not to bin, is explored in this great article by Stephen Few. The fundamental question is it better to use bins, where different colors are assigned to different intervals, or is it better to use a continuous color scale, where individual numbers are mapped directly to colors? One argument for binning is that you can only perceive so many different colors. A related argument for using continuous scales is that when small differences occur in adjacent polygons, then you can see the difference clearly, even if you wouldn't be able to see the difference if they were far away. Here's a choropleth map that uses a continuous color scale. Notice how you can perceive the difference between these two. Here's a visualization of the same data using 7 bins, and these two fall into the same bin. So you can't see that there's a difference at all. To even know that there's a difference, you would need to rely on external means like tooltips. So it is totally possible to use a sequential color scale and not use bins at all. The answer to the question, to bin or not to bin, is really, it depends on the task at hand. But anyway, the main problem that I had with this data set is that it's not complete. There are a bunch of countries that have missing data. Fortunately, in this piece, they explore another data source that is much more complete and has, for example, data about the United States. This is the same metric, but it comes from a different source, IHME, Global Burden of Disease Study. And on this page here, you can go to the sources and find out where this data really comes from. And IHME, by the way, stands for Institute for Health Metrics and Evaluation. If you click on the Data tab here, you can just download this data as a CSV file. I'm going to go ahead and publish this data as a gist so that we can visualize it. Here's my downloaded CSV file. It turns out you can just drag and drop files into GitHub Gist. Now that file has been populated. I'll add a README file by clicking Add File, then typing readme.md as the file name. This dataset was downloaded from, I'll make a link, copy the URL, copy the title, Our World in Data, HIV/AIDS by Max Rosser and Hannah Ritchie. I'll turn on wrapping so I can comfortably type. This data originally was sourced from, and then I'll find this source, IHME Global Burden of Disease Study 2017, and then I'll put the link to that data extraction tool. And then I'll say create public gist, and finally I'll give it a title. Right here, I'll give it a title of IHME HIV/AIDS dataset. And then I'll hit Update Public Gist. Now this data set is available for us to pull into our visualizations. Now we have everything we need to replicate this visualization using React and D3 so that we can eventually take it in new and different directions and even use the Choropleth template to visualize other data sets.